They're asking us to find the degree, the leading coefficient, the constant term, and the max number of zeros for these polynomials. So you can see I got 4 examples today. That's it. And the green ones are all polynomials that are in one variable. Like in number 1, there's nothing but c's. I don't care if they're to the 4th power, 7th power, or whatnot. In number 3, there's only x's. In number 4, there's only x's. And you can see in number 2, they have x's and y's. So let's start with the beginning one. The degree of the polynomial is going to be out of all these terms, like check out all the terms. The terms are separated by either addition signs or subtraction signs, or also even equal signs. But there's 4 different terms in this one. Which one of these 4 terms has the biggest exponent on it? And are we cool that it's the pink guy right here? The pink guy, its exponent is 7, so that means the degree of that guy is 7 in this case. Because this polynomial should be written in standard form. It doesn't have to be, but if it was, it would look like this, where the terms go from highest degree to lowest degree. So the 7th degree guy comes first, then the 4th degree, then this guy. It doesn't have to be written in standard form, because all you got to do is find the term with the biggest exponent on it. And then the leading coefficient of that polynomial will be whatever the coefficient of that term is. So that would be 14. The reason why it's called the leading coefficient, because if it was truly written in standard form, he's the lead off in that case. That's why it's the leading coefficient. The constant term is the term with no variables in it. So in this case, it's the 2. Right? And then the max number of zeros that a polynomial can have, man, we're going to learn so much more about this, but it's whatever your degree is. Your degree is 7. That is, of course, if it's in one variable. As you can see on number 2, I got an x in this guy. The max number of zeros doesn't work. It's got to be a polynomial in one variable. So let's kind of jump down to number 3 real quick and just check that guy out. The degree of this guy is a 2. He's the biggest exponent you see on each individual term. The leading coefficient is the number in front of that, which is a 1. The constant term is the guy that has no x's or letters with it whatsoever. And then the max number of zeros is the same as your degree, which is 2. But if we had this guy up here, which has more than one variable with it, they might ask some homework questions just about the degree of these guys. You have to realize in these terms are separated by addition, subtraction, or equal signs. There are 4 terms. You got to actually add these exponents together to see what the degree of each individual term is in this case. So the biggest one is our degree in this guy, which is a 7. Right? So then the leading coefficient is the coefficient of that term. He's not 3, he's negative 3 because of that minus in front of there. And then the constant term, dude, there is nobody there. So he's a 0 in that case. But you won't get really very many questions this chapter when there's in more than one variable, except for maybe on today's homework. So let's go back to the normal guys. Here's a guy only with x's with it. Find the degree. He's the term with the biggest exponent on it. So this guy has a degree of 4, and that leading coefficient is negative 2. The constant term is this dude right here. He is a 17 because he has no x's with him, and the max number of zeros is 4, baby. Why is it 4? Because whatever your degree is. That's the fundamental theorem of algebra, which we'll talk much more about this chapter, but this is a nice little preview. Let us know if you have any questions. Have a good one.